An interesting fact about doing field observations is that you can end up with an enormous amount of data, and you cannot report everything. No journal is going to take all of that. So you got to think about ways of sampling your data, and that's what this segment is all about. There's two categories of sampling. Subject sampling is the first one, where you focus on which animals you're going to actually look at among a population of animals that are out there. And the second category is what we call event sampling, that focuses a little bit more on the specific behaviors. These two are actually intermingled with one another. You can't divorce one from the other. But in terms of trying to categorize different sampling techniques, they kind of divide up this way. So subject sampling and event sampling. So first, we're going to look at subject sampling. Ad libitum sampling. Okay, it's not really sampling. You record everything. You're basically recording everything that you possibly can. Now, you're going to miss stuff. That's just taken as a given. But you try to record as much as possible. Well, why would you want to do that? Well, it's best used when there's already little information available on whatever it is you're dealing with, whatever it is you're observing, or that particular species in particular, or you're just simply unfamiliar with looking at this particular type of behavior or this particular type of animal, whatever the species happens to be. So to familiarize yourself, you just try to record as much as possible, at least initially. So it's called ad libitum. It's really not sampling. Okay, so our first real form of sampling is called sociometric matrix, where you're interested in looking at social interactions among individuals. Typically, it's done if you're studying dominance relationships, trying to form a dominance hierarchy. So for example, here we have a muskox. Notice the padding on its head, which is an incredible adaptation for what I'm about to show you, because this is how males compete for dominance status. So backing up and charge and bam, right in the head. This has to hurt. I'm not a muskox, I don't know, but it has to hurt. But it rarely does physical damage, at least as far as I'm aware. And they'll just keep going at it. I've edited this way down. They were at this for quite some time. We're just seeing the last portion of this. And boy, that guy over on the right looks a little bit wobbly. They both do, but especially the guy. He also looks smaller, but it could be the photographic angle. Let's see what's going to happen here. Okay, he's had enough. So we can see who the most dominant animal is between the two of them. So they're competing for females, and so the females actually are off watching this take place. And so the dominant male is going to end up with the choice females, or maybe the most females. It depends on what species we're looking at. So let's look at this in sharks now. Okay, so a whole bunch of sharks. So this is a real study that was done, and I'm only showing you a subsample of the data because he actually looked at many more sharks than this in this particular group. So just the initials that the researcher gave to these sharks. And here's how you do the sociometric matrix. Oh my gosh, it looks like a transition matrix, and it's very similar to the transition matrix that I showed in the segment on sequential analysis. So these are those sharks right there, challenging sharks, and then we're going to take the same sharks, right, and these are the sharks giving way. Okay, line them up that way. Now, a shark cannot give way to itself. They don't challenge and then give way to itself. There's no way that can happen. So these cells will always be empty. Okay, TW can never challenge TW, and so on and so forth. So those are empty data sets right there. So we're interested in the other ones. So look at this. G gave way to TW twice, and TW gave way to SL 5 times. and G gave way to SL twice. And now we just fill out the rest of this, and you get a sense of what's going on. Okay, so with these numbers in mind, you can now start to ask questions about the dominance hierarchy. Who's the most dominant shark? Who never gave way? L. Never gave way to any of the other sharks, and it was challenged, by the way. I'm not showing you those data. It's not that it wasn't challenged, it was. Never gave way. The least dominant, well, look at the columns. So here's where column totals. I didn't put a line in for column totals, but you can do the simple math. Obviously, the least dominant is TW. It gave way 16 times. None of the other sharks gave way that many times. So now, based on the data that I'm showing you here in this watered down matrix, sociometric matrix, you can now line up the dominance hierarchy with L being the most dominant, TW being the least dominant, and all of the others falling in between based upon the number of times that they gave way. So that's sociometric matrix. Focal animal is another form of subject sampling where you observe only one animal. Does that mean you really observe only one animal? What if that animal disappears behind a rock or in the vegetation or whatever? So no. Then you can shift your attention to another animal. But, all things being equal, you would look at only one animal. It's not all that useful, but it can be depending on the kind of question that you're interested in addressing. Scan sampling is used a lot, actually, as a form of subject sampling. So what you're doing here is scanning an entire group of animals at fixed intervals. And you note the behavior of each individual animal in each of these scans. The scan is actually like taking a camera and sweeping it from left to right or right to left. I think left to right, for whatever reason, seems to be the most conventional way of doing this. And in fact, it's very difficult to do this unless you're filming or videotaping, as I'll try to illustrate right now. So here's some, I'm about to show you some videos that I made at the beach down in St. Pete Beach in Florida when I was there for a conference. Okay, and we're going to be looking at some gulls, a very small group of gulls. And suppose I say we're interested in whether they're preening their backs or preening their fronts. So their front. Front. Okay, so here's what we're going to do. There's 3 possibilities in the video. Preen front, preen back, or none of the above, other. So here's how you would go about doing that as we look at this. Here's our first scan. I'll try to get this correct. I'm not sure if I can. Front, back, front, scan 2, back, other, back, scan 3, back, other, back, front, sort of. You do this one. I'm going to shut up for this last one. So you can see that, yeah, some of these are a little bit ambiguous because I didn't say, well, what if they're preening their side? Is that the front or the back? I mean, technically, if I was really collecting data, I would have included that as a category. I'm just trying to give you an idea of what's going on here. Okay, here's a short video. I've edited this way down as well. I think it's 3 scans of a larger group of animals. This was done at the Minneapolis Zoo, and the person who was illustrating this is actually indicating what these animals are doing. So these are pronghorns, and she's interested in whether they're feeding or not. If it's feed, she says feed. If it's other, she says other. This is a larger group of animals than we just saw with those gulls. Check this out.
other, 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 feed, 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 other, feed, feed, other, 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 other. Record other 8 times. Other, 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 feed, other, 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 other.
You can see where this could be really, really difficult. And normally you would actually be using like a check sheet. You'd be just checking these things down. But if it's a large group, you'd probably be recording into some kind of a recording device and then transcribing it later. So it gives you an idea of which behaviors occur more often, basically, in a group of animals. Scan sampling. The more you do it, the easier it gets. You do have to be aware of biases, however, especially if you're looking at a group of animals and one happens to be a little bit more conspicuous than the others. You might miss something. Now, again, this is why it's important to actually go ahead and photograph or obviously videotape if you're really doing scan sampling. When I made this photograph, I was not doing scan sampling. I was just photographing displays of ducks for a paper I was writing. Now, when I photographed this, interestingly, the only display I saw was this. It's called a grunt whistle. These are domestic mallards, by the way, Peking ducks. And what I didn't realize is there's 2 other displays going on. At the time I photographed this, I only saw one. But then when I looked at the photo, I realized, oh my gosh, that guy over there is doing a head up, tail up, and that female in back is doing what's called nod swimming. Totally missed it while I was watching the animals live. So it's really important to have recording equipment with you if you're going to even attempt to do this kind of stuff for real. Again, I was just trying to get some photographs. Okay, let's move on to event sampling. Now, the Esterline Angus event recorder is what used to be used for this procedure, but now we have computerized devices instead. But they basically follow the same kind of a pattern that the Esterline Angus did. And so here's how it worked. I mean, there's different pens in this event recorder, and this piece of paper moves in a path like this. It's really the same as a polygraph, except it's not. You're not recording physiological data. And then the person has a keypad, and each letter is coded with a different behavior. And you could actually make it more complex, and you typically would actually, by having combinations of letters. So A might be one behavior, B might be another, but AB might yet be another. And you can have as many combinations as you can try to keep track of here, depending on how many behaviors you're looking at. So each behavior is given its own track. Okay. And every time you push the button, the pen would actually deflect upward. And as long as you keep your finger on the button, it would stay in that upward position. Then you remove your finger and the pen goes down to baseline. That's how you would collect these data. So here's what it would look like if you were starting out with the complete record. So now complete record, we're not sampling. It's like ad libitum for subject sampling. So you're going to record the timing and duration of all, or at least a subset of the behaviors you're interested in. So again, it's not really sampling. Now you can start with this, by the way, and then later on use it to sample down with the other event sampling techniques. So let's do that. Here's the complete record. So these are points along a timeline in seconds, starting with 0. That's when you're going to start, and then 5 seconds, 10 through 20. Okay? And suppose we're only going to look at 3 behaviors. Keep it simple. There's A. So this is the event recorder layout. Let me just show you, again, if you're not clear. Baseline, the behavior's not occurring. It starts to occur. It's still occurring. It's still occurring. It stops. Stop, and then it occurs again. And it occurs that long, and then it stops. It occurs again, stays there, and then it stops. And then it doesn't. Out here it occurs again, stops over there, and so on and so forth. Okay, so now I think you're following this. So that's the pattern of behavior B. And that's the pattern of behavior C. That's our complete record. Now let's look at the actual sampling techniques from the complete record. The first one is called 1-0. So with 1-0 sampling, you're going to look between each interval, between 0 and 5 seconds, between 5 and 10, between 10 and 15, etc. And assign a 1 to each behavior if it occurred, or a 0 if it didn't. So let's do that. A. Did A occur between 0 and 5 seconds? Yeah. Gets a 1. Did it occur between 5 and 10 seconds? No. Gets a 0. Did it occur between 10 and 15? Yep, sure did. What about 15 to 20? It did. Okay. And then after 20, it didn't. Okay, so we'll fill in the rest. Notice that in sampling this way, you're losing information. You're losing how often the behaviors occurred. It's either it occurred or didn't within each time interval, not how many times it occurred or how long it occurred. You're losing all duration data as well. So you have to decide whether or not those bits of information are important to you. If they are, you don't want to be using 1-0 sampling. Okay? Now, with time sampling, what you're going to do is record which behavior, if any, is occurring at each fixed interval. Typically, you would do this by having some earphones on, perhaps, with some kind of a timing device that goes off, say, every 5 seconds or every 10. It depends on what you're looking at and how often the behaviors typically occur in terms of what the interval's actually going to be. But notice what you would get in this data set. So at 0, right at the beginning, A is occurring, and B and C are not. At 5 seconds, C is occurring. At 10, C is still occurring again, even though it's a new episode of C. 15, it's A again, and at 20 seconds, B is occurring. And depending on the behaviors, I mean, some behaviors are so tightly linked with one another, conceivably you could have two behaviors occurring at exactly the same time, though maybe not quite exactly. So normally it'll be one behavior or no behaviors. If none of these were occurring, you would just put 0 or something or leave it blank. Sequence sampling with repetitions. Well, this goes back to the sequential analysis that I showed you, kind of, except without a transition matrix. So with repetitions, notice what's going on. We're just going through this and recording temporally across all A, B's, and C's what is happening when. So A, and then C, and then B, and then B, and then C, and so right on down the line, and that's the sequence that you end up getting. Now, at some time, there might be some reason where you're not interested in a behavior following itself, so you could do a sequence without repetitions, and so you're not worried about A following itself 2 more times. So you would just do A, C, B, C, A, B, A, B, and that would be without repetitions. So those are the typical types of sampling that ethologists use when observing organisms in the field. And it's actually been applied to human observations as well.